You can create AWS Step Functions using AWS CDK. And in this video, I will show you exactly how. There are two main ways that you can use CDK to create step functions. First, by loading an existing ASL into CDK, and then also by using native CDK constructs to define your workflow in code. I will start with a simple example with the CDK constructs, and then we will see more advanced cases where you can integrate with existing AWS resources. I will also show you how you can define workflows and also create the related AWS resources that's required to deploy those steps. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is part of my AWS Step Functions series, and thanks to AWS for sponsoring it. Today I'll be using Visual Studio Code to walk through the code that I have already written. Here I have the existing solution that I have used in the previous videos in this series. Now we have the user onboarding workflow, which is the Lambda function that's used in the workflow. We also have the API that was used to trigger the workflow. Now, the new folder that I've added is Step Functions, which is created using CDK init command. Now, if you're completely new to CDK, I highly recommend checking out my Getting Started with CDK video, which will be linked here and also in the descriptions below. Now, using the CDK init, I have created the CDK project structure, and we have the source folder where we have the Step Functions folder, within which I have already written out multiple stacks so that you don't have to sit here watching me type out the CDK code. We will be walking through each of these stacks and the different use cases and see how we can create step functions using CDK. Now, assuming that you're already familiar with step functions and have watched some of my previous videos in this series, we will first dive into the mechanism where we were creating workflows earlier. This was using ASL files. Now, I have a user onboarding ASL file here, which we saw that we can visualize in Visual Studio Code using the extension, and we deployed this directly from Visual Studio Code as well. Now, this ASL file is nothing but a simple JSON file at rest. So you can see the full JSON structure in the code window. Now, we can use this existing ASL directly within CDK. So if I open the user onboarding using ASL stack file, here we have a CDK stack which defines the state machine. Now, this is specifying the name and the definition body of the state machine. Now, for the definition body, I'm directly loading this from the ASL definition. Now, for this, all I have to do is read the entire ASL as a string and then pass it on into the definition body. I've also specified that this is a standard state machine type. You can also choose between express and standard. For the state machine to run, we need to specify the appropriate roles. So I'm using an existing role that I had already defined in AWS for one of my previous workflows. So this state machine role gives the entire role that's required for this ASL to execute. Now, to deploy this, all we need to do is run CDK deploy and specify the stack name. In this case, in the program.cs, I've already configured all of this in here, which means I can directly run this stack. So let's navigate into the correct folder, which is going to be step functions, and we can specify CDK deploy and specify the stack name as well, which is user onboarding using ASL. Now, once we run this, it is going to run the CDK deploy and deploy this stack into my AWS account. So you can see the status here. It has successfully created the stack and also deployed the workflow function. Now, we have specified the name in here, which is user onboarding CDK ASL. So let's navigate into my AWS account and let's refresh this. So here we have the user onboarding CDK ASL workflow created. So let's navigate into it and click edit, and you can see the full workflow being deployed. You can execute this as in the previous videos. Now, this is the most straightforward way to use CDK with step functions. You're directly using the ASL and loading it. However, we are not using any of the advantages that CDK provides with the native constructs, etc. Now, CDK also supports a mechanism where you can directly define the workflow within CDK code. So let's navigate back to Visual Studio Code and open the step function demo stack. Now, inside this, I'm using native CDK constructs to define the workflow. So you can see here, we have a pass state, which is simply getting the details from the input. So you can see we are using JSON path expressions in this case, and it's reading a user from the input and assigning it to a variable. Now, we are also defining a wait state and waiting for 5 seconds. Now, the last example is using the JSON expressions that we have seen, where it's creating a new pass and creating a greeting message from the user variable that we set earlier. Now you can see this is using JSON expressions, which we saw in the previous videos. Now, once we have defined all these states, we can build the state definition. Now, in this case, I'm saying pass state, and the next after that is the wait and then the JSON pass. Now, this has created the definition by chaining these different states that we created in CDK. Now, note that all these constructs are native CDK constructs. So you can see the pass is a CDK construct, which is inheriting from state, which further inherits from CDK construct. Now, once we have created the definition, like before, we can create the state machine and specify the definition body from this definition. So we're using definition body from chainable and passing in the definition chain. Again, we are specifying the machine type, and we can deploy this using CDK deploy. So let's copy this stack name and let's navigate to the console, and let's specify CDK deploy and pass in the stack name. Now, this time it is asking to give access to create these resources. So let's specify yes, which is going to create all these resources. Now, since in this example, I have not explicitly specified a role, it is automatically creating a role which gives some default access. The CDK stack deployment is successful. So let's navigate back. Let's go to the state machines and refresh this. And here we have the CDK demo state machine. So let's navigate into that and click edit. And here we can see the state. So we have the pass with parameters, the wait state, and also the state that used JSON expressions. Now let's click execute to see this in action, and let's specify an input. In this case, I'm using the same user input that I've been using in the previous videos, and click start execution. Now you can see this is going through the state and it's now waiting, and it will also pass through the next state. Now if you look at the pass with parameters, you can see the variables that it's defining. So in this case, it is defining the user variable and also the timestamp variable. Now in the JSON pass, we were assigning some value. So you can see in the input output, and you can see the output as greeting hello John Doe, which is coming from the input that we gave. So this is able to successfully create a workflow using CDK constructs. Now in this case, we haven't created any AWS resources, and it is a simple workflow. So let's see how we can build more complex workflows. Now if we navigate back into Visual Studio Code and open the CDK out folder, we can see the synthesized output. Now in this case, we have the step function demo stack template.json. So if we expand that, you can see the full ASL for the state machine directly here. So you can see the definition string, which has the start at and also passing in all the state information. So CDK, when it's running synthesize, it converts all this chainable action that we have defined in here into an ASL and puts that in the definition body. Now I have written a script with the help of AI to extract this ASL from this CDK synthesized value. So here I have extract ASL PS1, which is reading through those files and doing some processing to output an ASL file. Now if I was to run this, so let's run the extract ASL PS1, it is going to extract all of this and put this inside a folder inside this root folder. So you can see there is an ASL generated. Now it has generated all the other ones, but let's look at the one that we are interested, which is the CDK demo stack. So this, you can see this is an ASL that it has copied out from the CDK out file. Now you can use this to visualize the state machine that you're building with CDK constructs. Now, one of the main things that I miss when using native CDK constructs is this visualization. It makes it much more easier to understand the workflow and also drag and drop and create this workflow to the start. But you can always create this ASL and then use AI or manually write out the code using the CDK construct by looking at the ASL. Now, this comes down to a preference on if you want to maintain an ASL to deploy your workflow or you want native CDK constructs. But let's look at the next example where we have the user onboarding CDK and recreate that using constructs. Earlier we saw the user onboarding ASL, and I have used AI to automatically create this stack from this ASL function. In this case, I'm creating the CDK constructs and not natively loading it from the ASL file. So you can see here, I'm loading the from table, user onboarding function, which is the Lambda function, the onboarding queue, etc. Those are the external resources. And we are creating the pass state and also the states to call the AWS service. Now in the first state, we are having the states.input and mapping it out. And we also have call AWS service, which calls to the DynamoDB put item and puts the item into that. Now these are all native CDK constructs. Similarly, we can also use Lambda invoke using the call AWS service by specifying the service name and also the action to invoke. Now we have specified the function name and given the function ARN here using the function that we loaded using the ARN. We can also specify this function name from this onboarding function if you want. Now, I will be having this source code in GitHub where you can detailedly go through this construct definition, but we are recreating all that we had in the complex workflow, which is the user onboarding.asl.json using CDK constructs. So we have specified the choice state, the retry function, and also handling exceptions. Now, once we've defined the whole state, like before, we chain them together. We also specify the error paths, and once we have the entire definition built up, we can create the state machine and pass in the definition. Now, when creating a state machine, you can define the default query language to be used by all steps. Now, in this case, I'm specifying it as JSON expression. Now, you can override this at individual steps by again specifying the query language if you want to opt in to JSON path. Now, with the workflow defined, we can deploy this. Let's grab the stack name, which is user onboarding CDK stack, and let's run CDK deploy and pass the stack name. Now, this again is going to create the entire step function, this time around using the native CDK constructs. Now, while that is synthesizing and deploying, let's look at the generated ASL. So if we open the user onboarding CDK script that we have here, you can see this has created the exact same workflow that we had before in the ASL file. Now, this is completely created by CDK constructs. Now, the deployment is in progress and it's complete, which means we can navigate back to our AWS console, go to AWS state machines, and here we have user onboarding CDK. So let's navigate into that and edit this, and you can see the full step function in here. Let's execute this to see this in action. Let's paste in the data, let's pass the user object, and let's click start execution. Now this is going to pass through the different states that we have here based on the conditions that we have defined, and it has sent the message and also invoked the Lambda function. Now up until now, we were using the existing resources that we had created before. However, there is no need for that because since we are already in CDK, we can define the AWS functions and resources that the function requires within the CDK itself. Now, there might be scenarios that you're integrating with existing AWS resources that other applications talks to, like an XQS message or an SNS topic, etc., in which case you can just load it like here. However, if you have specific AWS resources for your step functions, it's easier to manage them as part of the same CDK stack. Now, let's look at an example where we have a user onboarding CDK with resources stack where I am explicitly creating all the resources. Now, in this case, I'm creating a DynamoDB table. I'm specifying the primary key and the hash key in here. Now, with the table created, I'm also creating the queue and also the Lambda function. So you can see here there is a function called, and I also deploy the function code from this specific folder. Now this is specifying the handler and it's copying the code asset from this user onboarding workflow. Now we can also write the code in CDK to actually build the project so that it publishes out the output that needs to be packaged as code. Now here I'm using .NET Publish and publishing it for Linux x64 self-contained and publishing it as a Lambda function. Now, once we have defined the function, the SQS, and the table, we can define the state machine as before. Now, here we are also specifying the role because we already have the resources created in CDK. So, we are specifying the state machine role and granting permission to write to the user table, invoke the function, and also send message to the queue. Earlier, we had to manually create these roles. However, all of this is now done in CDK. The rest is as before. We have created the pass state, called AWS servers, etc., and passing in the user table, the details in here, and also the ARN because all these resources are directly created in this CDK script. Now at the end, we are again creating the state definition and passing in the details that's required. Now to deploy this, let's copy the stack name and let's run CDK deploy and pass in the stack name. Now this time around, this is also going to create the AWS resources, create the role, and then the entire step function. So let's grant access for this and then it'll start creating. So if I navigate back into the ASL generated, you can look at the user onboarding CDK with resources. Now the ASL for this is exactly the same as before. The only difference that we have done here is all these resources that we require, which is the DynamoDB, the Lambda function, and the SQS, is now created as part of this CDK stack. So let's wait for this to complete. Now you can navigate into your AWS console. Let's navigate into CloudFormation where you can see this stack being deployed. Now you can see this is create in progress. So if I navigate into that, you can see the different resources that it's getting created. So the user table, the onboarding queue, the function, etc. has been created. Now you can navigate into the user table if you want. So let's open this. Here, this is a fresh table that is created for us. So if we explore the table items, there are no items in here. Now the workflow creation is complete, which means we can use our workflow function. So let's navigate into state machines and navigate to user onboarding CDK with resource. Let's click start execution. And let's paste the user details and click start execution. Now this is going to run the workflow. So it's created the DynamoDB put item and calling the invoke and send an SQS message. So if I switch over to the DynamoDB new table that was created and refresh this, you can see the new entry being made in here. You can also see the different Lambda function and the other resources that's part of this and see also that they were invoked. So if I navigate into this Lambda function, you can see the log stream here, which is just invoked, and you can see the information that's logged by the Lambda function. So we were successfully able to create the step function using native CDK constructs and also create the resources that's required and deploy it successfully. Now, whether you use between CDK or the ASL is the team's choice. Now, there are certain advantages by using CDK and also there are advantages with using ASL. By using ASL, you can easily drag and drop in the builder and define the workflow. Whereas with CDK, it is in code and also you're using native constructs, which means it is much more maintainable and you can easily modify it as well. Now, like I showed you, you can use the script to extract out the ASL and visualize it, or you can even define the ASL and then use AI to help you build the CDK. Once you give a few of these examples of the ASL and the equivalent CDK constructs, AI can easily generate these classes for you. Now, all the demo that I have shown you was code generated by AI with a bit of tweaking from my side. This will be available in GitHub for you to look at and walk through and use in your projects as well. In the next video, I will show you how to set up a build deploy pipeline so that when you commit this, it automatically deploys the workflow and also the resources from a GitHub pipeline. If you want to be notified when that video comes out, please make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.